Hello, my name is Professor Johnson, and today I will show you how to deal with percentiles. Now, percentiles are a way to measure location. I will be using this formula. Truly, there are many different formulas out there for finding percentiles, but I like this one, so I'm going to go with this one. K is what's called the kth percentile. So if we had the 25th percentile, for example, I would put 25 in the K location. Now I divide that by 100 to make it into a decimal. And then I multiply by this thing, n plus 1. When I multiply by n plus 1 here, I'm going to need the total number of data points. Now, you'll have to just count and you'll get the total number. The I is what's called the index. Now the index will not be your final solution. This is just helping you with the location, okay? It's just helping you with where the location is. So first things first, you need to order your data. Now when you found the 5-number summary previously, you order your data anyways. So I have wrote it in order. This data set comes from a previous video I've made, and I will post that link for you to go watch up in the corner. Now, going down here, 5-number summary, you have the minimum, quartiles, median, quartile, maximum. That summary is from the previous video, but I want to practice this new formula. I equals K divided by 100, n plus 1. Now I need my n. So let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. N is equal to 14 in this particular example. And you can see I'm still using that same data. But let me put my n equals 14 up here because I'm going to need some room after finding the index. So finding my index. This question asked for the 50th percentile. Now recall, the 50th percentile is equivalent to the median. 50th percentile, median, right in the middle. Imagine 50-50 split. So 50th percentile, K will really be 50. N is 14 from before, add 1, and we have to solve this. So 0.5 times 14 plus 1 is 15. So what is 0.5 times 15? Enter. 7.5. Now, look up here at the data. 7.5 is not our answer. Can you imagine where 7.5 really is located? 7.5 is near 7. But does that look like it splits the data in half at 50? Definitely not. We know the true answer should be 14.5, thinking back to what we had before when you found the 5-number summary. But this is telling us 7.5. When the index lands on a decimal, you need to go to the 7th spot and the 8th spot. Because 7.5, you need to round down and you round up. Now the spot, index is the location. I will number this now. 1, 2, 3, 4, 5, 6, 7, 8. You need to go to the 7th spot and the 8th spot. You put those together and average them. So at the 7th spot is 14. You add it to 15, divide it in half. And we have found previously that this is actually 14.5. This is our final answer. This is really the 50th percentile, or otherwise known as the median, and it's also known as quartile 2. So we have found our first percentile with that formula. It gave us the location and we sought it out and found it. Let's go to another example. Find the 40th percentile. Notice the 40th percentile isn't on one of those nice quartiles, so you definitely need to use the formula here. I would be equal to, you have to do K over 100, n plus 1. Now this is the Same data set that we had before, so I know n is still 14. K now is 40, and you multiply by, you get 15. Remember where 15 came from? It was 14 plus 1. 40 divided by 100, you can imagine you could move the decimal place twice because you're dividing by 100, gives you 0.4, and then you're multiplying by 15. Now, hopefully, we get a nice value. 0.4 times 15 gives you 6. Okay, but remember what I said about 6. This is a location. This is not your final answer. If you think about where 6 is located, that's right down here between 4 and 7. That is not the 40th percentile. You could think the 40th percentile would be where it splits 40% of the data, the lower part is 40%, and the upper part is 60% of the data points. So, the 6 tells us to count. 1, 2, 3, 4, 5, 6. Circle that 6th point. 12 is the 40th percentile. So, let's do the 70th. I equals k over 100 n plus 1. This is equivalent to 70 divided by 100. N is 14. You add 1. Move the decimal place twice. You get 0.7 multiplied by 15. Use your calculator. 0.7 times 15, 10.5. Remember what to do when it lands on 10.5? Really, you need to look at 2 spots. Go to the 10th spot and the 11th spot. So, let's also count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. What happens when you land on 2 numbers? You need to average them. So you take 16, add it to 18, divide in half. Now remember, if you use the calculator and want to do it in one step, put the numerator in parentheses and then hit divide by 2. If you do not do that, you will get the wrong answer. 17 is the 70th percentile. And 17 lands right between 16 and 18, so I know my answer made sense. But if you looked at the index, right, remember the index that we had was 10.5. 10.5, if you look at your data set, right up here, 10.5 is close to there. That is not your final answer. 17 is your final answer. 70th percentile. Which is telling me that 30% of the data points are up there and then 70% are all down here. It's splitting it at that location. Rewrite our formula. I equals k over 100, n plus 1. K is 95 because we're looking for the 95th percentile, multiplied by 14 plus 1. And we can move the decimal place twice because you're dividing by 100, and we know, as before, that was 15. So 0.95 times 15 gives you 14.25. Now, this is 14 1/4. Remember, we know that the total number of data points is 14, right? If I number this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14.25 as an index goes beyond our data set. So really we don't have to look at any averages. We just need to stop at the very last number. The 95th percentile would truly be 30. So how about we do an example with the 90th? If it was the 90th, we would do 0.9 times 15. That would give me 13.5. So let's look at that. Let's actually find the 90th percentile. The 90th percentile, I just rewrote it, would be 0.9 times 15. and that comes from the pattern that we've been doing before, and you get 13.5. That tells me to go to the 13th spot and the 14th spot and find the average. So if you look up at the 13th and the 14th spot, 22 plus 30 divided in half. Remember, put it in parentheses. 22 plus 30, divide it in half. You will get 26. So 26 would be the 90th percentile, which lands approximately there, and that would be our final answer. It is possible with small data sets that the 90th percentile could match like the 91st percentile or the 93rd percentile, right? Let me demonstrate. If I put 0.93 times 15, that's going to be 13.95. So you round down to 13, round up to 14. Notice the 93rd percentile is also 26. So in small data sets, this can happen, and you just have to watch out for it. It just is telling you approximately the location of data. Thank you for watching my video.